So this is the continuation of the previous lecture. In the previous lecture, we explained the basic definition of even and odd signal and the basic equations of uh, to find the even component and odd component of a signal. We also discussed how to find the even and odd component by using graphical methods. Okay. Now mainly we'll discuss the remaining questions in analytical method. So in this question, we need to find the even and odd component of the signal x of t is equal to e raised to jt. Okay. So we know that in order to find the even component of a signal, we need to use the formula uh, xe of t, or I can write xe of t can be written as x of t plus x of minus t whole divided by 2. Okay. Now, in this particular question, x of t is given as e raised to j t. But in order to find the even component of the signal, we required x of minus t. So we can find out x of minus t. Simply replacing t with minus t. So now we can write t is changing to minus t. So we can write e raised to minus j t. Now we need to substitute these two quantities in xe of t. So you can write xe of t is equal to, in place of x of t, you can write e raised to jt plus in place of x of minus t, you need to write e raised to minus jt whole divided by 2. So if you look at this particular equation, and if you compare with the Euler's formula, cos theta can be written as e raised to j theta uh, plus e raised to minus j theta by 2. So by rearranging this particular equation, we can write this term e raised to jt into e raised to minus jt by 2 can be written as cos t. Okay. So this is the even component of the signal. Now we need to find out the odd component of the signal, and the odd component of the signal can be written as x of t is equal to x of t minus x of minus t whole divided by 2. Okay. So in place of x of t, you can substitute e raised to jt, okay, minus e raised to minus jt divided by 2. But if you look at the Euler's formula, you can see that sine theta is equal to e raised to j theta into e raised to minus j theta by 2j. And if you observe this particular equation, you can see that this is j term is missing. So I can put a j uh, in the denominator, and in order to cancel, we can put a j in the numerator also. So you can see that the remaining portion is equivalent to sine. So you can write j into sine t. So we got the even component is equal to cos t, and odd component is equal to j sine t. Okay. Now we can verify this. Okay. E raised to jt, or we can say that e raised to j theta is equal to cos theta plus j sine theta. If we look at this particular equation, this cos t part is the even component, and j sine theta is the odd component. And if you add these two signals, you will get x of t. So any signal can be written as the sum of its even component and odd component. Now, in this particular question, we need to find the even and odd component of the signal x of t is equal to u of t. And this u of t is actually the step signal. Okay, it's a singularity function. So we'll write the basic definition of u of t. Okay, u of t is equal to 1 for t greater than 0, and 0 for t less than 0. Okay. and we can draw this particular signal, and it's a continuous time signal. So x-axis will be t, and in y-axis I can write the magnitude, that is u of t is equal to what. So this is 0, and if t is greater than 0, signal magnitude is 1. This is actually x of t. Now we need to find out x of minus t, and x of minus t means you need to write u of minus t, and u of minus t is equal to 1 for minus t greater than 0, or you can write t. If you multiply this equation with minus 1, you will get t and 0, so you need to change the sign. Okay, and 0 for minus t less than 0, or if you rearrange this, or if you multiply with this equation minus 1, you will get t and 0. So now we need to change the sign. So you can see that the signal magnitude is 1 for t less than 0. So u of minus t you can draw like this. U of minus t means this is 0, and if t less than 0, if t less than 0 means towards left, the signal magnitude is 1. Okay, so this is a signal x of minus t, or you can write u of minus t. So we got two signals. Now we need to find the even part of the signal. So in order to find the even part of the signal, you need to write xe of t is equal to x of t plus x of minus t by 2. So you can add these two signals. So you can draw the even component of the signal, that is xe of t, uh, which is equal to x of t plus x of minus t whole divided by 2. So for that, if you compare the positive side of the signal, this is 0. The positive side, the signal magnitude is 1, and for u of minus t it's 0. So you can write it becomes 0 plus 1 by 2. So you'll get 1 by 2. And similarly to the left side, here it is 0. During negative side it's 0. For u of minus t it's 1. So again you will get half. So 0 plus 1 divided by 2. So you are getting 1 by 2. Okay. So the answer is equal to 1 by 2. Now we need to find the odd component. So to find the odd component, we need to use the formula x odd of t, which is equal to x of t minus x of minus t divided by 2. So if you take the positive side, the first signal, that is for u of t, it's 1. Okay, and for the second signal is 0. Okay, so 1 plus 0 by 2, so sorry, 1 minus 0 by 2, so you'll get 1 by 2 here. So this is 1 by 2. And for t less than 0, for the first signal it is 0, for the second signal it is 1. So you can write 0 minus 1 by 2. So it becomes minus 1 by 2. So for the negative side, you will get minus 1 by 2. And now we can conclude that for even signal, the signal is 1 by 2, and for x odd of or odd component of the signal, for the positive side it is 1 by 2, and for the negative side it's minus 1 by 2. So we can write the final equation in a standard form. There is a signal called signum. Okay, signum function, which is written as signum of t, uh, which is equal to 1 for t greater than 0, and 0 for t equal to 0, and minus 1 for t less than 0. So if you draw the waveform, it will be like this. This is a signum function, and this is t, and for t is equal to 0, And if t greater than 0, the signal magnitude is 1, and for t less than 0, the signal magnitude is minus 1. So this is signum of t. And if you compare this particular equation, there's only difference, the amplitude is 1 by 2 here. So we can write simply 1 by 2 signum of t. Okay, so this is the odd component, and even component is simply 1 by 2. Okay, irrespective of the value of t is always 1 by 2. But in the case of odd component of step signal is 1 by 2 sine t. And if you add xc of t plus x of t, you will get the signal u of t. Okay. Now we'll discuss the next question. Find the even and odd component of the signal x of t is equal to sine omega t plus pi by 4. And in order to find the even component, the formula will be e xc of t is equal to x of t plus x of minus t by 2. And we already know x of t, so we need to find out x of minus t. X of minus t will be, we can replace t with minus t, so we can write sine omega minus t, so into minus t plus pi by 4. And if you rearrange this particular equation, you will get sine, and if you take minus outside, so you'll get omega t minus pi by 4. Okay, and we know that sine minus theta is equal to minus of sine theta. So based on that, you can write minus sine omega t minus pi by 4. And now we know that x of t and x of minus t. Now we can find the even component xc of t. So xc of t is equal to, first we need to write sine x of t, that is sine omega t plus pi by 4 plus x of minus t is minus sine omega t minus pi by 4. Okay, the whole divided by 1 by 2. So if you look at the equation, you can see that it's simply sine a minus sine b. So you can rearrange this equation. It becomes 1 by 2 into uh, sine a minus sine b is equal to 2 cos. So you can write 2 cos a plus b by 2. So you can see that this is a and this is b. So a is omega t plus pi by 4, and plus b means you need to write plus omega t minus pi by 4, the whole divided by 2 into the other part is sine a minus b. So this is actually a plus b by 2. Okay, now we need to write a minus b by 2. This is a plus b by 2. Now we need to write a minus b by 2. So a is omega t plus pi by 4 minus b. So b is actually omega t minus pi by 4. And if you apply the minus sign, you will get minus omega t plus pi by 4. Okay, the whole divided by 2. So you will get a minus b by 2. Now we need to simplify this equation. So you'll get 1 by 2, and there's a 2 and 2. You can cancel these two values. So it's simply 1. Okay. Uh, and if you write this equation, it becomes cos omega t plus omega t becomes 2 omega t, pi by 4 and pi minus pi by 4 cancel. So divided by 2. Okay. This is the first part, and the remaining part sine will get 2 pi by 4 by 2. And if you rearrange this, it's simply pi by 4. Okay, So you can write sine omega t into uh, sine pi by 4. And sine pi by 4 is 1 by 2, 1 by root 2. So you can write 1 by root 2 sine omega t. So this is the even component of the signal. Now we need to find the odd component of the signal. So in order to find the odd component of the signal, you need to write the equation x of t, which is equal to x of t minus x of minus t whole divided by 2. So if you write x of t, it's simply sine omega t plus pi by 4 minus sine x of minus t is equal to uh, already there is a minus, so minus into minus sine omega t minus pi by 4 and the whole divided by 2. So this equation becomes plus, so you'll get sine a plus sine b. Okay, so that you can write 2 sine a plus b. So you can write omega t plus pi by 4 plus omega t minus pi by 4. Okay, that is sine a plus b and whole divided by 2 into the second term is actually cos a minus b by 2. So you can write cos a is pi by 4 minus b means minus omega t plus pi by 4. Okay, so the whole divided by 2. And if you rearrange this, you'll get 2 sine, it becomes 2 omega t by 2. So you can write omega t into cos. Okay, already there's a 2, so you need to write the 2 also. So 2 cancel. Here it is cos pi by 4. Okay, now if you simplify this, you will get cos pi by 4 is 1 by 2. So you can write 1 by root 2 uh, sine omega t. So this is the odd component of the signal. Okay, so if you take this particular question, sine omega t plus pi by 4, uh, the even component of the signal is 1 by root 2 sine omega t, and an odd component is 1 by 2 sine omega t. Okay, sorry, I made a mistake here. It's actually cos, so we need to write cos here. Okay, this is cos actually, so it is cos omega t. Okay, this is sine and this is cos. Now we need to discuss discrete time signal, which is given by e raised to j omega n plus pi by 2. So we need to use the formula for discrete time signal. So x e of n is a discrete time signal. Its even component can be written as x of n plus x of minus n by 2. So this is the even component. So already x of n is given. Now we need x of minus n. X of minus n is equal to e raised to j omega into minus n and plus pi by 2. Okay, and if you rearrange this, you will get e raised to, so if you rearrange this equation, you will get e raised to minus j omega n uh, plus j pi by 2, because j is common, so I can split these two terms, e raised to j omega minus n plus e raised to j pi by 2. Okay, and similarly the other term, And if you split this particular equation, you'll get e raised to minus j omega n into e raised to j pi by 2. Okay, by Euler's formula, we know that e raised to j theta is equal to cos theta plus j sin theta. And in place of theta, it is pi by 2, so you will get cos pi by 2 plus j sin pi by 2. And in this particular case, cos pi by 2 is 0 and sin pi by 2 is what? So we'll get g. And you can simply replace this particular equation, j e raised to minus j omega n. And now you can think about this x of n. X of n can also be written as x of n can be written as e raised to j omega n into e raised to j pi by 2. Okay, and this e raised to j pi by 2 is j, so you can write j e raised to j omega n. Now we can apply the formula xc of n. uh, xc of n is equal to x of n, that is j e raised to so xc of n is equal to j e raised to j omega n plus j e raised to minus j omega n the whole divided by 2. So you can take j outside, and remaining, if you group, you will get e raised to j omega n plus e raised to minus j omega n whole divided by 2. And if you compare with the Euler's formula, you can see that this is cos theta form. So you can write j cos omega n. So this is the even component. Now we need to write the odd component of the signal, x of n. So here we need to substitute x of n, that is j e raised to j omega n minus j e raised to minus j omega n the whole divided by 2. And if you rearrange, you will get j into e raised to j omega n minus e raised to minus j omega n whole divided by 2. But if you compare with the Euler's formula, one j term is required in the denominator, so you can put that j term here and you can multiply j. So j is imaginary term, so you will get j into j minus sine omega n. Okay, so this is a odd component of the signal. Now we can discuss another question. We need to find the even and odd component of the signal x of n is equal to del of n. So this is an impulse signal. So we can write the definition of an impulse signal. Del of n is equal to the discrete time impulse signal. So del of n is equal to 1 for n is equal to 0 and 0 for n not equal to 0. So this signal, when n is equal to 0, the signal magnitude is 1. And we know that this impulse signal property, that is impulse signal is an even signal. So del of n is an even signal, means del of n is equal to del of minus 1. Okay, so in order to find xc of n, we need to use the formula x of n plus x of minus n by 2. So instead of x of n, you can write del of n, and in place of x of minus n, you need to write del of minus n by 2. And in place of del of minus n, you can write del of n because it's an even signal. So you'll get 2 del of n by 2. So simply you will get del of n. Okay, because this del of minus n can be written as del of n. Now we can compare, write odd component of x of n, which is equal to x of n minus x of minus n by 2. And here it is del of n and minus del of minus n whole divided by 2. So this del of minus n can be written as del of n. So del of n minus del of n, because del of n is an even signal. So del of minus n is equal to del of n. So you'll get 0. So the even component is del of n and odd component 0. We can also conclude result from the first part itself, because the given signal is an even signal, so it only contains the even component. There is an odd component because del of n is an even signal, so there is no need to find the odd component of the signal because it's 0.